To understand mesh networks, we must understand how they are different from typical network architectures used to connect our devices, such as phones, computers, and routers. These devices usually connect in what is referred to as a hub-and-spoke network architecture. Hub-and-spoke networks are centralized networks in which points on the network, the spokes, are all connected to a single center, the hub, which serves as an access point through which all devices on the network connect to all other devices. In a mesh network, the network architecture is not as defined. Rather, the devices on the network connect to all other devices on the network that are nearby. The devices, also known as nodes, send data to other nodes that are within range, and the data moves through the network node to node until it reaches its final destination. But what are these nodes? They can take many forms as long as they can send and receive data. Typically, they are made of wireless routers, just like the ones you use at home. They can also be made of cell phones or radios. For a mesh network to work, however, each node has to behave a bit differently than it would if it were connected to a typical network. It must not only send and receive data, but it must also determine an efficient way to send data across the mesh. The nodes accomplish this through what is known as a routing protocol. A routing protocol is a set of rules that are coded into the nodes, which uses either the local or global makeup of the mesh to determine the best path by which to send the data. There are various algorithms that are used for this, including OLSR, Batman, and HWMP. Even with these algorithms, many nodes forwarding data around the mesh can create network traffic, which can sometimes lead to network congestion. For what can we use mesh networks? Well, first, it can be used to share an internet connection. However, many of the most interesting uses of mesh networks don't involve the larger internet. Mesh networks can host their own servers, so their users can communicate and exchange information across the mesh network itself without being connected to the larger internet. The nature of mesh networks and their routing algorithms also brings about many interesting properties. First, they are self-healing, as the routing protocols find multiple ways to send data across the mesh. Even if a node drops off, as long as the mesh is contiguous, it will continue to function. Second, they are generally self-discovering and configuring. When new nodes join the mesh, the routing protocols automatically integrate them into the data transmission paths. They are also relatively inexpensive to implement. Many mesh networks are built with nodes consisting of wireless routers that can be purchased for less than $40 US. This is one of the reasons why many interesting applications of mesh networks can be found in the developing world. In order to solidify our understanding of mesh networks' significance, let's take a look at some real-world examples of their use. Some commercial applications, such as Orinoco mesh access points, combine mesh principles with Wi-Fi nodes to afford commercial enterprises in metropolitan areas the ability to provide internet access to their entire operation through one hardline access point. This allows businesses to expand capacity along their personal networks while extending the range of said networks as a mesh, as opposed to having a series of individual routers, each connected to a wireline backbone. One Laptop Per Child, a nonprofit organization dedicated to providing children with rugged, low-power, internet-capable laptops, has successfully tested mesh networking over their XO model laptops at connection speeds of up to 5 megabytes per second, and over a kilometer in distance. At these speeds, OLPC laptops can support a wide variety of mobile applications, including long-distance video chatting without an internet connection. In 2010, ham radio enthusiasts calling themselves the South Texas Balloon Launch Team utilized high-altitude balloons and water towers to deploy a mesh network of routers connected to the internet around a suburb of Austin, Texas. Applications such as these could prove very useful in emergency situations, during which mesh networks could be relied upon to support basic telecommunications applications, such as sending email and images between interconnected devices. As these examples demonstrate, mesh networking can serve a variety of purposes. With greater investment in the technology and more widespread adoption by the public, mesh networks could revolutionize and democratize the way people share data.